morning and welcome to the African Utility Week studio. I am Ashley Turan, content editor of ESI Africa. And joining us this morning, we have Robert Mubiru, distribution management consultant from the Energy Utility Corporation Limited.
Good morning.
Thank you for joining us.
Thank you. Yes.
How's your stay been here so far?
It's quite good. Very pleasant as usual, always. Yeah.
Oh no, great.
Yes.
So Robert, for the focus of this interview, I would like us to look at local content. And just judging by a lot of the stories and in the media and just with some research, there's a perception that the importance of human capital is often pushed to the wayside when utilities are drawing up their budgets.
Yeah, well, that's a very good and sensitive observation, I must say. I think that's general. It's not only on utilities, but across mainly the nuts and bolts type of industry. Obviously, when it comes to consultancies and like accounting firms and things like that, it's the human capital that makes up the direct value add. But when it comes to manufacturing concerns, utilities, and industry of that sort, there's a tendency to focus on what they call inputs, and they forget that one of the major inputs is the skills and the people who actually make those inputs and turn them into a value add for whatever the industry is. So that's where the utility sometimes may be accused of not focusing so well. Mainly in terms of managing the full life cycle of the onboarding, induction, settling, growth, career trajectory, and management of each person right through their life cycle as an employee, which is so critical. I mean, I can talk on and on, I don't want to chew up time, but when you look at certain aspects and facets of a utility, let's say protection, let's say planning, even maintenance and faults, it's all the people. Yes, they're helped by technology and you need the materials, you need the cars and everything, but it's the people who are putting everything together and making it work. And the more skilled they are, the better you look after them, the more motivated they are, the better, first of all, the more efficient, the more productivity you get out of every single hit by a person. And then the better your bottom line, because you won't need as many people to do what you need to do, and they'll do it faster and better and higher quality. So
we're seeing a lot more smarter and more efficient technology coming into the market.
Yes.
How does this therefore influence or impact human capital, specifically within the operations and maintenance space?
Okay, that's great. Just like the transformation we've seen in industry with the introduction of technology, I think for industry the most prominent thing has been robots and how smart and quick they've become. But if you notice, even the most high-tech and slick manufacturers, the aircraft manufacturers, the car manufacturers, still remain with significantly large numbers of staff, but they're doing different things. What happens is you end up with a staff, a workforce that is higher up, more into the management of the technology and application or monitoring of the technology to deliver. And the technology comes in to automate certain aspects of the utility and automate certain outputs. When it comes to maintenance, what you'd have before was the basic monitoring and operation of equipment out in the field. By and large, by now, is almost worldwide translated into remote monitoring, remote control of equipment. And you're having certain installations that are less and less manned, in certain cases not at all manned, even full-blown generation stations. But then beyond that, we're beginning to introduce sensors and all kinds of transducers to try and improve the quality of data that's coming out and help better monitor the performance of an item, help us schedule and prioritize maintenance to help. We had this discussion about where do you apply your maintenance and how do you tweak your maintenance to make sure that it's actually scratching the right spot? That's where it's coming in. But then you need people to analyze the data and make sense of it, and so the workforce is being transformed into more of analysis and management and programming, prioritization of works based on better, higher quality information coming out from the installations. So the people are becoming of a higher skill level and more sophisticated, and so they need even more complex management, because you know how it is managing elite staff rather than people who are doing more routine tasks.
And this data analysis,
yes,
is that something which is focused in-house, or are utilities looking outside for experts?
Now, what's happening is very interesting, because I don't know why, but on the African continent, first of all, the whole concept of operations and maintenance is still lagging in terms of modern methods. Okay. And most of the modern methods that are being used in the BRICS, like here in South Africa, and have been established, I mean, the cutting edge is in New Zealand, where they've really pushed the envelope, have a motivation. They're mainly driven by the bottom line. So you're trying to tweak the efficiency of the utility as much as possible, and you're fine-tuning your operations and your works. And in the African context, sub-Saharan Africa, the whole concept of efficiency in utilities is just beginning to take off. It's few places where they're really beginning to start, entering that second phase of saying, okay, we have an efficient utility, but to move to the next level, we have to use this type of technology. We have to start using these methods. So there's a whole sliding scale of the spectrum, the majority of whom are still at the adoption phase of efficiency concepts, or the concepts of an efficiently run utility, before you start introducing technology for really fine-tuning. Because still in sub-Saharan Africa, it's not strange or rare to find a utility that has 40% losses. And that's just that in itself tells you that the basics have to be done. Let's get the management of the utility right. Let's that type of thing before you start introducing the technology. So I know this is a kind of a roundabout way of answering that question, but the thing is, we're not yet at a level where we're actually starting to adopt that technology. However, the type of analysis that you need to do, especially on the maintenance side, would be first condition monitoring. Once you start doing your condition monitoring, then you can prioritize your maintenance activities. What that does, it helps you tone down the maintenance, the routine maintenance on less stressed assets. Therefore, you don't need as many interventions, saves you money, and then you focus your activities on the more stressed assets. And it actually does follow Pareto's rule. It's about 30 or 20% of the assets, even in some of the worst utilities, that tend to be more stressed. And you actually look around and you find some assets that are idle, lightly loaded, hardly engaged. And those ones you don't need to. So once you get your condition monitoring in place and that data flowing on a regular basis, then you can start prioritization. The next thing is moving to the next level, where people are talking about predictive maintenance. And that's now where you start getting the consultancies in, and you start having consultancy type services or service provision by elite service providers, say like GE, who that's one of their flagship products that they're pushing, predictive maintenance. They'll say, we'll walk into a power station and we'll hook up our sensors on this machine. And because of the history of these type of machines and where we've worked, we'll be able to tell you predictively that because of this component is at risk, that component is at risk. So change it beforehand. And you're doing minor tweaks and interventions to keep the thing going, rather than major shutdown type maintenance. And that's predictive maintenance. As you can see by the explanation, it tends to be a lot more complex. So the analysis tends to be offshore, and that data and its interpretation is done on board with the utility.
So Robert, just briefly, looking at that adoption timeline,
yes.
What would you say is a realistic time frame for moving along that line for a utility?
Now, there's so many parameters. There's so many parameters. First and foremost, there are things that people normally don't want to talk about that are very serious influences along that sliding scale. Whenever you start transforming a utility, you're always talking about painful adjustments both internally and externally. And they require a lot of goodwill and determined resolve at the top. And when I say the top, I mean the very top. You're talking the leaders of the country, of the nation, because a utility affects the economy. A utility is dealing with a very, very major component of life as we know it in any country. So changes must be well understood and bought in at the top, such that they'll support transformation of the utility. That's when you start actually moving towards efficient operations, accountability, both economic, operational, and environmental and social in the utility, regulation that's independent and things like that. You notice all of that has to be in place before you can even start having consistently efficient utilities. That's why we have 40% losses still. Not that the skills are not there, it's that willingness across the board to say, guys, no, enough is enough, this is what we need to do. Then there are the other issues of cost and understanding that we need to take this journey if we're really to start managing our costs and start managing the end user price and things like that. So that's why I'm saying that it's hard for me to predict. But let me just guess. Let's assume that we are all committed. Everybody's committed, we're going to go through the pain. And let me just give you a small, brief understanding of what I mean. The two countries that I'm aware of where some of this transformation, in-depth transformation has been done, in both cases, the steering committee has been made up of ministers, cabinet ministers, and they have had weekly reports to them. It required a change of the law to change the structure of the energy sector so that you can actually move into a mode where you start pushing for efficiency and it's embedded going forward. So I'm going to start off saying the law is done, the cabinet is committed, and the structures are in place. Okay. It takes about 5 to 10 years for real efficiency both to be culturally embedded and accepted and consistently applied with benefits accrued, evidenced. So now I'm talking, if I were just to look at losses, moving down from a loss level about 40% down to about the early 20s to late teens. Because it's beyond that you start having to do a lot more efficiency. That's when you have to start applying technology and whatnot, because most of the major inhibitors, the usual administrative type stuff, have been handled. Staff are working productively, the management has made the utility lean, operational practices are done routinely, data is collected, reports are on time, the data is there in place. So about 10 years. Now for the adoption of technology, you first have to scope it and make it environmentally specific and fit within the context, and that normally takes from scoping to procurement about another 5 years, and then embedding about 3 years. So if you really want to have proper adoption of this technology, I would hazard a timeline around 10 years, starting from now, with all the commitments. Now I'm assuming that nothing has been done in the sector, and you're starting from a green field. But obviously there are many utilities where most of the governments have recognized that things have to change, and changes have been done and structures are in place.
So Robert, just to conclude, I think that we can say we need strong, clear leadership from the top.
Oh yes. Very seriously.
Robert,
yes.
Thank you so much for joining us this morning.
Yeah.
It's an absolute pleasure as always.
Thank you.
And thank you to you for joining us.